Integration in logical learning.
Today we will be talking about measurement and experimentation. Now, what are the systems of unit and the units in SI system? The need of unit for the measurement, the system of unit, the unit of length, mass and time, the fundamental and the derived units, the unit writing guidelines, and the measurements of the length, least count of measuring instrument and vernier calipers, and also the screw gauge. I think we all are very much familiar with these terms. Now let's discuss them in brief. The need of unit for the measurement. Suppose there is a following scenario. You went to a grocery shop and asked for 10 meter sugar, or you went to a cloth shop and asked for 15 kg length of cloth. Is it funny? Where you have done mistake. In the units, now you understand the importance and the choice of units in our day-to-day life. Now, by definition, unit is the quantity of the constant magnitude which is used to measure the magnitudes of other quantities of the same nature. Now, the definition of physical quantity is the subject or the quantity which can be measured directly or indirectly, through which the laws of the nature are expressed. It is also known as the physical quantity. Physical quantity is equal to the numerical value into the unit. Now let's discuss about the types of units, fundamental units and the derived units. Now what are fundamental units? It is independent of any other unit, or it neither be changed nor can be related to any other fundamental unit. Now what are derived units? These units depend on the fundamental units, or this can be expressed in terms of fundamental units. The system of units can be divided into three parts. The CGS system, or the centimeter gram second, the FPS system, or the foot pound second, and the MKS system, or the meter kilogram second. Now we need to note one thing, that is the MKS system, the enlarged version that has been taken as the system internationally units SI system. Now there are some examples of the derived units. For the quantity of area, the definition is length into breadth, and the derived unit is meter into meter, so the symbol is meter square. For the quantity of volume, the definition is length into breadth into height, and the derived unit is meter into meter into meter, so the symbol is meter cube. Now for the density, the definition is mass divided by volume, so the derived unit will be kilogram by meter cube, and so the symbol will be kg meter to the power minus 3. Now for the force, the definition is mass into acceleration, which means kilogram into meter per second square, or Newton, and so the symbol will be kg meter second to the power minus 2, or Newton. Now for work, it is force into displacement, which means kilogram into meter per second square into meter or joule, and the symbol will be kg meter square second to the power minus 2, or joule. Now here are some other derived units as well. You need to go through this and remember them as well. Now let's talk about the fundamental quantities and the units with symbol in SI system. There are other two quantities, angle and solid angle, whose units are radian RD and steradian STRD. The quantities here are length and the unit is meter, so the symbol will be M. For mass, the unit is kilogram and the symbol is kg. For time, the unit is second and the symbol is S. And for current, the unit is ampere and the symbol is A. Now you need to go through this to remember them wisely. Now what is the unit of length? The SI unit of length, meter M. 1 meter is the distance travelled by the light in a vacuum or air in 1 by 299,792,458 of a second. Now the sub and multiple units of meter. Different units and their relation are given below. The multiple units are kilometer km, hectometer hm and decameter dam, and the subunits are decimeter dm, centimeter cm and millimeter mm. Now there are some non-metric units of length as well. The bigger units are astronomical unit AU, light year LY and parsec, and the smaller units are angstrom, Fermi F. Now there are some bigger units of length as well. It says one astronomical unit is equal to the mean distance between the earth and the sun, which means 1 AU is equal to 1.496 into 1011 meter. Now what is a light year? A light year is actually the distance that is travelled by the light in vacuum in 1 year. So basically 1 light year is equal to the speed of the light. So 1 year is equal to 3 into 10 to the power 8 meter per second, which is 365 into 24 into 3600 second, which is equal to 9.46 into 10 to the power 12 kilometer. Now what is parsec? 1 parsec is the distance from where the semi-major axis of the orbit of Earth subtends an angle in 1 second. So 1 parsec is equal to the arc length divided by the angle in RD, which is equal to 3.08 into 106 meter, which is 3.26 ly. Now there are some smaller units of length. 1 Armstrong is equal to 10 to the power minus 10 meter, and 1 nanometer is equal to 10 to the power minus 9 meter. 1 Fermi is equal to 10 to the power minus 15 meter, and 1 microM is equal to 10 to the power minus 6 meter. Now what is the unit of mass? The SI unit of mass is kilogram, which is kg. So 1 kg is defined as the mass of a cylindrical piece of platinum iridium alloy kept at the International Bureau of Weights near Paris. The subunits of kg are gram. 1 gram is equal to 1 divided by 1000 kg, which is equal to 10 to the power minus 3 kg. Milligram mg is equal to 1 milligram, which is equal to 10 to the power minus 6 kg, which is 10 to the power minus 3 gram. Now the multiple units of kg. Quintal. 1 quintal is equal to 100 kg and 1 metric ton is equal to 1000 kg. Now what are the non-metric units of mass? Atomic mass unit AMU. It is 1 by 12 mass of carbon 12 atom, which is U equals to 1 divided by 12 into 12 divided by 6.02 into 10 to the power 26 kg, which is 1.66 into 10 to the power minus 27 kg. Now let's come to the unit of time. The SI unit of time is second S. So 1 second is defined as 1 by 86,400th part of a mean solar day. 1 millisecond is equal to 10 to the power minus 3 second, and 1 shake is equal to 10 to the power minus 8 gram. Now there are some bigger units of time as well. Minute, hour, day, month, year, leap year, decade, century and millennium. Now let's quickly do some numericals to understand this in a far better way. Question number 1 says the wavelength of light of any particular color is 5800 Armstrong unit and express it in A, nanometer and B, meter. Now we know 1 Armstrong is equal to 10 to the power minus 10 meter, which is 10 to the power minus 1 nanometer. So 5800 Armstrong is equal to 5800 into 10 to the power minus 1 nanometer, which is 580 nanometer. And number B, 5800 Armstrong is equal to 5800 into 10 to the power minus 10 meter, which is 58 into 10 to the power minus 8 meter. So we have got the answers. Now question number 2 says the wavelength of light of any particular color is 589 nanometer. Now what is its value in Armstrong unit? We know 1 Armstrong is equal to 10 to the power minus 10 meter, which is 10 to the power minus 1 nanometer. So 1 nanometer is equal to 10 Armstrong unit, hence 589 nanometer is equal to 589 into 10 Armstrong, which is 5890 Armstrong, and we got the answer. Question number 3 says the distance of a star from the earth is 5 light minutes. Express the distance in meter. So first of all you have to write 1 light minute is equal to speed of the light into 1 minute, which is 3 into 10 to the power 8 into 60 seconds, which is 1.8 into 10 to the power 10 meter. Hence 5 light minute is equal to 5 into 1.8 into 10 to the power 10 meter, which is 9 into 10 to the power 10 meter. Question number 4 says the size of a virus is 1 micron and find the number of the virus in 1 meter length. We know that 1 micrometer is equal to 10 to the power minus 6 meter, and hence 1 meter is equal to 10 to the power 6 micrometer. In 1 meter, the length number of virus is equal to 10 to the power 6. Now there are some guidelines which we all need to follow while writing the units. The units which are associated with the name of a scientist would be in capital letters. Example, Newton N, Coulomb C, etc. All the others will be in small letters as gram G, meter M, etc. Now the full name of the units, irrespective of the fact whether it is named after the scientist or not, is always written with lowercase. Example, the units of energy is joule and not joule, where the J is capital. The units in its short form is written never in plural. Example, 10 meters cannot be written as 10 ms. If a compound unit is formed by 2 units multiplication, there are dot or cross or leaving space between the two symbols, the 2 units can be expressed. Example, the unit of torque is N dot M or N into meter or Newton meter. The negative power is used for compound units which are formed by dividing one unit by the another. Example, the unit of speed is meter per second, and it can also be expressed as meter second to the power minus 1. Thank you for watching this video, and if you have any queries regarding the measurement, you can put the same in the comment box below and we will surely be able to answer your questions.